A liquid of known surface tension, that may assume it is given as T, which I have not written in the problem, is kept in a container of cross section in a regular hexagon shape of side A. The liquid is now in a container of shape hexagon of side A. What is the surface energy that it has, right? So first let me try to write what's the formula for the surface energy is. That can be done basing on the definition of surface tension as work done to produce a unit change in the surface area of the liquid. Assuming that this is not initially in that container, it's work done by A final minus A initial. So it was not given that it's having in any other container earlier. That means it's having a zero area. It was brought somewhere. So work done by area of that hexagon has to be taken into consideration, right? So work done, which is stored as a surface energy in that liquid, can be found using a formula, surface tension into area of that hexagon. So we shall try to find out what is the area of that hexagon is. Yeah, let's try to find out. First, let me draw a diagram of that hexagon to find out the area of that hexagon. Yeah. Okay. Hexagon. 1, 2, 3, 4, 5, 6. Hexagon means having 6 sides of equal dimensions. So if I just draw the lines like this, what I found is there is 1, 2, 3, 4, 5, 6 identical triangles are there. So what's the area of that hexagon is? Simply what I can write, area of that hexagon is 6 times into area of identical triangle, equilateral triangle, each of side A. That's the side A, right? Area of equilateral triangle of side A. So now my task is to find the area of any of this equilateral triangle. Any of this equilateral triangle is my task. So what's the formula for the area of the triangle? Of triangle is having a formula of, must have learned it in a school, base into height of that equilateral triangle. Base is very clear, that is A. But I need to find out how much is this height h is. Right? How much of this height h is. This is area, this side is also equal to area. I want to find out this h. You can see here a right angle triangle very clearly. Yeah. Where I will draw the diagram once again as a different part of it. I will just magnify this diagram for my convenience, for our convenience. This is what it is. This is one side. This green shaped up. This is having the side of A. This is the half of that side. This part is half of that side. That is A by 2. This is H. I need to find out that H. In a right angle triangle, I can apply Pythagoras law as this square plus this square equal to this square. That is A by 2 whole square plus H square equal to A square. If you simplify this further a little, A square by 4 plus H square equal to A square. So H square equal to A square minus A square by 4. That is 4A square minus A square by 4. That is 3A square by 4. That is square of the height. That implies height H is equal to, make a square root on both sides, root 3. Square root of A square is A. Square root of 4 is equal to 2. Now I know the height of the triangle. I know the base of the triangle. That implies I can find the area of the triangle. Lies. Area of triangle is, as I told you the formula earlier, half into base into height. Half base is A. Be careful. For this, it's being a half of the triangle that is able to, but I'm talking about this entire triangle now. So A height is nothing but equal to root 3 A by 2. So the total area of the triangle is root 3 A square by 4. But we are talking about an hexagon. Hexagon is someone who is having 6 of these identical triangles. So area of hexagon is 6 times of area of this triangle, root 3 A square by 4. Now I got the area of the hexagon. I can use the very core definition of surface tension. What's the definition of its surface tension? Work done by change in area, that is area of the hexagon, because we have assumed initial area equal to 0. So work done equal to T into area of the hexagon, where T is the surface tension of the liquid. Assume that that's a given for us. The given answer, area of that hexagon, we have found as 6 root 3 A square by 4. So I can cancel with this and this, 2 3s and 2 2s. So 3 root 3 T square of that side of any hexagon by 2 is the answer for the work done, and that work is stored as a surface energy on the surface of that liquid. This is how we have to solve the problem, and we are keep on repeatedly using the same concept, same formula. Surface tension is defined as work done per unit change in the surface area of the liquid. By this time, you must have realized that what's the importance of this definition itself, right? Thank you for watching.